Our group is comprised of Bernardo Chavez, Brock Malone, Dan Trimment, and Kevin Van Hooser. For our Stat 220 project, we use the Chicago Food Inspections data that we gathered from Kaggle.com. For our project, we will be finding the correlation between variables in the Chicago Food Inspections data set in order to value health risks. We will be using all the data to create the most accurate observations of Chicago's food markets as possible. The data set contains over 17 variables and over 180,000 inputs that we will run through the mill to provide clean and effective data representations of the results of each inspection. The information has been open to the public since January 2010. These data representations will be useful for the layman in order to make healthy choices when choosing where to dine in Chicago, Illinois.
So for our data exploration summary, we began by analyzing our raw data. We did that by making a summary of just the raw data, just to evaluate some of the different variables, the things that go into the raw data and how they interact with each other. And then for our first graph down here, we analyzed to look specifically at risk, longitude, latitude, and results. And we started to do that in this graph by analyzing risk. Risk 1 represents a high risk, risk 2 represents a medium risk, risk 3 represents a low risk, and that's kind of the amount of the restaurants that had each individual type of risk. And we did that through a bar graph ggplot. And then in this graph, kind of used the same format, except we analyzed the amount of businesses that passed inspection or went out of inspection, failed inspection, didn't have an entry, or passed with certain conditions. And over here is just kind of a count of the amount of businesses that had each of those types of results.
For our research abstract, we wanted to kind of delve into the correlation and see if there's a correlation between longitude and latitude and the risk of each facility in the Chicago Food Inspections data. And some of those facilities include Popeyes, Domino's, Starbucks, Dunkin' Donuts, as well as your mom and pop shops. So as we went in, the first thing we did was clean the data set. And you can see that here. We cleaned it. And for the food safety, we made the risk 1 being high, risk 2 being a medium risk, and risk 3 being low. And as well as you'll see later on, the zeros are the alls and then the not applicable, so kind of just the outliers to that. And as we go down, you can see, so this is the longitude and latitude of Chicago, with the darkest colors being 0, indicating the not applicable, as well as the 1 being the high risk. So you can see the high risk is kind of like in this downtown area, and we also included a map with the actual downtown Chicago, with this being the very dark colors. And you can see the absence of plots up here is indicative of Lake Michigan. So you can see interpreting it, the more suburban areas and the further south you go, there's less risk, so that means that there's nicer restaurants. And that's kind of what we concluded from this research abstract. One potential problem we ran into with this graph in particular was that the shades of blue are hard to indicate what a 1 or a 0 is. So you can kind of just see where it's like a big blob, you're not really sure which plot is a 0 or 1, and that's a huge potential problem.
So after cleaning our data, our group wanted to look at the results variable again and then compare that to the risk variable and kind of see what type of correlation there was between those. So I guess in this first graph here, we have a similar graph to what we had seen before that kind of just lists out the number of businesses that had each individual result in terms of passing or failing or being out of business, stuff like that. And then we also have a count, a more specific count of all of those numbers, just to get into specifics. And then, so what we did here is we decided to clean some more. We assigned the fail result, the number 1, pass with conditions, 2, pass 3, and then we had some outliers here, as we said before, no entry, out of business, and not ready. We all assigned 0. And then we used ggplot to kind of represent the correlation between risk and results. For example, a high risk, number 1, we can see all the different businesses that had that one risk, that high risk, and then we can see their results from their evaluations. So we can draw some pretty interesting conclusions from this graph, such as, it's interesting that there's a lot of high risk businesses that ended up passing their inspections. Actually, that's the most common occurrence that happens. So, and then we can draw a bunch of other conclusions that are kind of similar to that by looking at this graph. And then we just clean some more. And that is basically
it. In conclusion, there seems to be some correlation between longitude and latitude, where the businesses are located, and the risk. But as I alluded to earlier, that is kind of an issue that makes this a little bit inconclusive, because you can't really definitively tell which plot is where in regards to like risk and color, especially in the downtown area. For future research, I think as a group we talked about it'd be really interesting to focus on one like chain restaurants, say a Starbucks for example, that has many locations in Chicago, and see that if their locations like downtown have higher risk as opposed to the ones on the suburbs, and that would kind of, by our predictions, it would yield the same results because we predicted that downtown would have higher risk.